The term was coined by Richard Franco Goldman in Music Quarterly when he was writing about the music of Elliott Carter. And he described it as the means of going smoothly but with complete accuracy from one absolute metronomic speed to another by lengthening or shortening the value of a basic note. The problem for our the definition is slightly vague for our purposes today, so I'm choosing to use Ronan Guilfoyle's. He's an Irish bassist, jazz pedagogue. He put out a book in 1999 called Creative Rhythmic Concepts for Jazz Improvisation, dedicated a couple pages, maybe 4 or so pages, to metric modulations in particular. And I like his, for my purposes, I like his definition of metric modulation as a modulation of the original meter, either upwards faster to a faster tempo or downwards to a slower tempo using a subdivision of the original pulse to decide the speed of the modulation. And that's key, a subdivision of the original pulse. An implied metric modulation versus a true metric modulation. So those are the two main categories I'm going to talk about. With both types of modulations, the rhythmic relationship between the new tempo and the original tempo is never compromised. The difference lies in how the original song form is handled. Okay, we'll get into that. But no matter, any metric modulation, either implied or true, that relationship, that ratio, the relationship between the original pulse and the new pulse never wavers, it's never forgotten about, it's always there. There's no fudging. So first let's talk about an implied metric modulation. When a metric modulation is implied, only the impression of a new tempo is created. Feel. So we've all seen, anyone who's read big band charts here or stuff like that has seen the term double time feel before. This is an implied metric modulation. It's an implication. It's not a true modulation. It's implied. It's instructing musicians to play rhythmically twice as fast, but the form of the song stays put. The chords of the song, the length of the song in terms of clock time, the harmonic rhythm, that is the time of each chord change, is the same in terms of clock time. So in double time feel is an implication, an implied metric modulation. Here's the challenge with implied metric modulations. Often the newly implied meter will obscure the barred lines of the original meter. Now in the case of double time feel, there is no obscuring because half note is a 2-to-1 relationship, so there's no obscuring in strong B's and count ones. But what if you start implying dotted quarters or other things? Then we start getting into tricky stuff where the bar lines get obscured, and that's when we start having to make decisions. True metric modulation. This occurs when the song form adapts to the newly modulated meter and tempo, thus creating a unified tempo and song form change. In this case, the song form is either stretched or shrunk in terms of clock time in order to accommodate the newly modulated tempo. Easiest example of this is double time. Not double time feel, but double time. It instructs the musicians to play everything twice as fast. The rhythm, the song form, the chord changes, the harmonic rhythm, everything goes twice as fast. Therefore, it's a true metric modulation. Modulations based on the duple groupings of eighth note triplets or quarter note triplets, that's the most common one. It's easiest to deal with, and I'll show you why. Eighth note triplet time, that is a modulation based on duple groupings of eighth note triplets. That's going to speed up the tempo. To be specific, if your tempo is at 120 and you decide to go into eighth note triplet time, your new tempo that you're implying, or that you're truly going to, whatever, the modulation you're going to is going to be you multiply the original tempo by 1.5. And then example 10. And then once you feel really comfortable with like 4-note triads, digital patterns, that type of thing, triad pairs, then go on to the scalar approach. Because you don't want to get stuck when you're improvising doing this. You don't want to get stuck in that patternistic box of just playing these triads and stuff like that, digital patterns. The goal is to have the same flexibility that you have with your normal subdivisions that you're used to, 8th notes, 16th notes. So if you do a chromatic scale, that's example 11. 12 is just a major bebop scale. In that halftime is a modulation based on the half note in 4/4 if your original pulse was a quarter note. And the original tempo is a quarter note. So the halftime is a half note, original tempo is a quarter note, middle time lies in between. It's based on the dotted quarter note. So again, the dotted vertical lines are representing your newly drawn bar lines as a result of the modulation. You'll find here that on the beginning of the 4th bar you have a coincident count 1. That is, the original tempo has a count 1 at the same time as the newly modulated tempo has. They line up for count 1 at the beginning of every 3 measures. So that's kind of like your rhythmic landmark. If you're playing along in middle time, when you get to the 3rd bar of middle time, you're at the top of the 4th bar of original time. 8 measures of normal time, and then 8 measures of middle time, and then 8 measures of normal time, and then 8 measures of middle time.
Sure. Back here?
Yeah, that's great.
I don't want to see well.
So it's just like you're driving along, and then all of a sudden you're in a slower gear all of a sudden. So it can be very musical. I'll show you some examples. This is off of Live at the Village Vanguard, Potter and Bill Stewart. This is a Bill Stewart composition called 7.5. It's called 7.5, I would imagine, because that's the form of the song. There's no B section. It's just an A section over and over again. And it's 7.5 measures in length. And at this point, you can probably guess why 7.5 measures in length. You don't have to worry about catch-up beats. So it's almost designed for middle time, this is. So it's 5 measures of middle time, or 7.5 measures of the original time. Most of the time throughout this recording, they're playing in the original tempo, but I'm about to play a chorus here where they go into middle time. It's spontaneous. Bill Stewart starts it, and he starts it right on the downbeat of the chorus. With the metronome, and this is the most difficult way to play middle time, to keep track of the original chords here. So hopefully there was a little bit of an illusion created